Hello, welcome back to Cracking the Cryptic for another episode. And today I'm going to be looking at this killer Sudoku by Mr. Menace. I'll get to that in a moment after congratulating a couple more people who have got to the finish line in the Build Your Own Sudoku puzzle hunt by Mattis Martinka. Brilliant puzzle hunt, some wicked steps in it. But sincere congratulations to Tuva Ekval and Andy Glidden, who both finished with the right answer. And sent it to us, so well done to them. And now, it's worth mentioning, there's tons of other great stuff on Patreon. Also Discord. Yesterday I mentioned that if you were thinking about setting and you wanted to know where to go, as John Landers did, Discord is the place. That's where some of the best setters in the world hang out. They're very welcoming, very warm. So I was a bit surprised, immediately having said that, to receive an email from somebody asking for us to put them in touch with 3 setters to work on an idea they'd had. Go to Discord. That's where it's going to happen. And finally, our apps. Also in the description field on the link under the video, you can find where to get all of our 6 apps, with the Arrow app coming soon. By soon, I believe I mean either this Friday or next Friday, but yet to be quite finished off. We don't quite know when it'll be, but Friday's apparently a very auspicious date to release these apps, and Arrow Sudoku will be coming out this month. That much I'm going to be confident about. Now, let's get to this puzzle. This is called Triples by Mr. Menace, and I believe that is because each cage in the puzzle is 3 cells large. Which is a really interesting arrangement. Fascinating that this produces a good puzzle, as I believe it does. Now, the rules are very simple. It's killer Sudoku. Normal Sudoku rules apply, and cages show their sums. You don't really need to know that digits can't repeat within a cage, because no cage gets out of a box here, so clearly digits can't repeat in it. Now, you might notice that there's one cage with no total. I think that's just to complete the symmetry of the decoration. It doesn't need the total for solving. And frankly, we can consider ourselves lucky. When Simon solved the first puzzle we did by Mr. Menace about a month ago, there were no cage totals in all the cages in the grid. So maybe I've got the longest straw. Anyway, straightforward rules. Do give it a try on the link under the video. I'm going to start now. Let's get cracking. And let's get cracking with a 6 cage, which has to be 1, 2, 3. Because the triangular number for 3 is 6, meaning that 1 plus 2 plus 3 equals 6. So that's the only formation possible. This 7 has to be 1, 2, 4. Now, that means that we've used up the 1 and the 2 for both row 8 and row 9. We don't know exactly how that's going to work. Actually, we do know that... Actually, we also know that's a 1, 2, 3, 4 quadruple. So the 3 in it must be there, so that's not a 3. And the 4 in it must be in the 7 cage, so that's not a 4. So in fact, we get a 1, 2 pair. The point being that we've used up 1 and 2 for row 8 and 9 in those cells. So the 1 and 2 in box 7 cannot be in those cells, and they must both be up here. And they can't both be in the 14 cage, or we'd have to stick an 11 in that cell, which would break all the rules we know and love. So this cell must be a 1 or a 2, and there's another one in one of these. The other 2 cells in the cage add up to 12 or 13, which is a bit variable. So again, this 8 cage has to have a 1. There are 2 possible arrangements of an 8. Could be 1, 2, 5 or 1, 3, 4. That's going to use up the 1s for columns 8 and 9, so there will be a 1 in one of those 3 cells. And what else? The 22 cages have 2 different possible arrangements, 9, 8, 5 and 9, 7, 6, which both include a 9, but they're not really seeing each other. It's worth noting, actually, that in each box we can use the secret, the knowledge of the 9th triangular number, to work out what the 3 cells that aren't in cages add up to. Because we know that 1 to 9 add up to 45, that triangular number, we can deduct the 2 cage totals in each box, because the box must contain 1 to 9. Some of those digits are in the 2 cages. Here they add up to 31. So the other 3 cells must add up to 14. Now, I don't know where that's going to help, but it probably will. Yeah, I mean, in this cage, the 3... Yeah, it's quite interesting. They add up to 19 as well as that cage. 19 plus 19 plus 7 equals 45. So both that cage and these 3 cells add up to 19. So one of them's got a 9 in, the other's got an 8 in. They can't go together or they'd need the 2. So one of those groups is 973, I think, and the other is 865. But I don't know which is which, so I can't really pencil mark that yet. These 3 add up to 9. Ah, yes, remember that 1, 2, 3, 4 quadruple. And that 1, 2, 3 pair. It's not a quadruple, that's a pair. Yes, 1, 2, 3, 4 leaves a minimum of 5 here. 1, 2 leaves a minimum of 3 here. And that already adds up to 8. And we know these 3 cells add up to 9. We can just fill them in suddenly. 1, 3, 5, making 9. We know that there's a 2 in this 14 cage. That goes with 12. Yes, we know that the 14 cage is made up of 2, 4, and 8. Because 2 needs another 12 to make 14. 12 in 2 digits is either 3, 9, but it can't be that in this box, or 5, 7, but it can't be that. So 2, 4, 8 in there, 9, 7, 6 in the 22 cage. This one can't be 2 because of the 1, 2 pair that we saw. These 2 definitely include an 8, but that's not useful, I doubt. Right, what else can we do? 39 in those cells. If they all had to be different, we would know they were 9, 8, 7, 6, 5, 4, but there can be repeats. Oh, look at these. What? Yeah, these are big numbers to be all together in the same rows. Right, what is the maximum total for 6 cells in row 4? 9, 8, 7, 6, 5, 4 add up to 39. What is the maximum for the 3 cells in row 6? This is beautiful. 9, 8, and 7 equal 24. You add 39, the maximum for those 6, to 24. The maximum for those ones, you get 63. And that is apparently the total of these cages. So they must all be max. I can do that quickly because obviously they average at 21, and 21 times 3 is 63. So 9, 8, 7, 6, 5, 4. I don't mind how many pencil marks I put in a cell. So they're all going in there. 9, 8, 7 forms a triple down there. And therefore these cells are 1, 2, and 3 in some order. I say I don't mind. I'm not going to put in the 1, 2, 3, 4, 5, 6 down there, but we've definitely learned something now. The 22 cage has to have a 9 in. I'm going to need to do something else looking up or down. This isn't quite enough. 22, 21, 31. These 3 add up to 14. Not that helpful. And these add up to 10. I don't know how to use that. Okay, what else have we got? Oh, here's something fantastic. Look, that 1 is ruled out of those cells. The 19 cage also cannot have a 1 in it, because if it did, the other 2 cells would have to add up to 18 and they'd both have to be 9s. That can't happen. So 1 in this box is now ruled into these 3 cells. Now, that does tell us, because we've used up the 1s for rows 2 and 3, that looks, oh sorry, I'm not managing to highlight them together. That looks slightly interesting in that we can put a 1 in one of those 3 cells in box 2. What's much more interesting about that is that this 9 cage now doesn't have a 1 in it, and then we know that that's 2, 3, and 4. So now we've used up this same using up the 2 instances in rows and columns is happening again and again in this puzzle. It's really, really elegant. The 2 and the 4 for columns, what are they, 4 and 5, have clearly been used up in these 2 little L shapes. Therefore, there are no 2s and 4s in, well, any of those cells in the boxes or these cells in the columns. So 2 and 4 in column 6 have to be in these 3 cells. That means the 4, which we know isn't here, is in the 10 cage. It can't be in the 10 cage with the 2, because then they'd need another 4 to make up the total. So the 2 has to be here. And that's a brilliant digit to get. That's really elegant. The 4 is in the 10 cage. That's got to be with a 1 and a 5 now. So it's a 1, 4, 5 cage. The 4's not there. 4 can't be in these cells. Now nor can 5, which has appeared in the box. So they are from 6, 7, 8, and 9. 6, 7, 8, and 9 add up to 30. What do we take off to get the 21? We take off 9. So we remove the 9, and that's a 6, 7, 8 set. We have 3 and 9 in the rest of the box. That's really pretty. Now, what else does that tell us? These have been reduced to 1 or 3. One of these is a 9. We know that. Don't know what else we know. 6, 7, 9. Presumably this... Oh, I know what we know. Yes, the 22 cage can't have a 4 in it, because it would need 2 more 9s. So the 4 in the row goes in one of these 2 cells. The 20 cage has a 4 in it, so it is 4, 7, 9. Oh, that's lovely. So that's a 4, 7, 9 cage. Now we've used the 2 7s in these rows, and we've got to have the 5 in this cell. So 5 is in there, 7s are not. Once 5 is in a 22 total, it has to be 5, 8, and 9, so we can take the 6s out of there. I'm going to remove the pencil marks, because obviously the pencil marks are clashing with the cage numbers a bit. So 5, 8, 9 there. Oh, we don't know what that cage adds up to, but here, 4, 7, 9 there. What do we know about the 15 cage? Oh no, what do we know about this 12 cage? We've used up the 9 and 7 in columns 2 and 3. So this is not 9, 2, 1, or 7, 4, 1, or 7, 3, 2. There are still a number of possibilities, but... Oh, maybe we don't know much about it. It could be 8, 3, 1. Okay, what about this 15 cage? No 9, 7, or 4. So yes, if it didn't have an 8 in it, once 9 and 7 are gone, if it didn't have an 8 in it, the only combination is 6, 5, 4. That's impossible because 4 is gone in this box. So it does have an 8 in it. And then we need another 7, which can't be 4, 3, but can be 5, 2. No, it can't be 5, 2. It's going to have to be 8, 6, 1. The reason it can't be 8, 5, 2 is because given that 5, you'd put a 5 in this cell, and these two would be 2 and 8, which would allow you to make that a 4 and that nothing at all. It wouldn't work. You'd have too many 2, 4s and 8s in 4 cells there. So it's not 8, 5, 2. It's not 8, 4, 3. It's 8, 6, 1. And that means this cell is a 3. And we are cooking with gas now. So 3 there, 1 there. Those don't have a 1 in anymore. These two cells are a 2-5 pair. There is a 3 in one of these 3 cells, given where we've decided 3s are down here. It could just be in this. Oh, it could easily be in the 12 cage. Okay, maybe it wasn't quite as helpful as I was hoping. 5s, yeah. Oh, there's going to be something else going on here. What am I missing here? 1, 5, 8, 9, 2, 7, 3, 4, and 6 still to place. This cage not having its total is very obstructive at this point. Ah, look, a 1, 2, 3, 4 triple. That is, isn't it? Yes, it is. So this is not 3, so we've done that one. 9 there, 3 there. That's not a 3 now. That 1, 2, 3, 4 triple doesn't tell me where 5 goes in the column. Oh, we're probably forming these sort of doubles and triples everywhere. 4, 7, 6, 9. We sort of are. Okay, so these are from 2, 3, 5, and 8 up here. Is it worth thinking about what can go in the 12 cage? 2 and 3. Well, let's start with 8. 8 and 5 is too much. 8 and 3 would need a 1 here, which is possible. 8 and 2 is not possible because you'd have a 2 here. So 8 and 3 is possible. 5 and 3 would need a 4 here. 5 and 2 is not possible. It would need a 5 here. 3 and 2 is possible, needs a 7 here. But every one of those possibilities is used a 3, I think. 2, 5 doesn't work because there's a repeat. 2, 8 doesn't work because there's a repeat. And 8, 5 doesn't work because it's too much. So we are using a 3 in this cage, which is really important, not so much for that cell, but for the fact that now we've got a pair of 3s used in the row. And that's helpful looking at this 8 cage. If the pair of 3s has been used in the row, this doesn't have a 3 in it over here. This must now be a 1, 2, 5 cage. And now we can do the same sorts of thing again. We've got 2 used twice in columns 8 and 9. So we can put a 2 in one of these. This is so neat. We've had a 5 used twice in columns 8 and 9. So now we get a 5 in one of those 2 cells in the 20 cage. So there's a 4 in one of those because it can't go with the 5, or we'd have to have an 11. Oh, is that it? Don't peter out here. 1, 2, 3, 4. So that's not where the 1 is. So the 1's in the 16 cage. With another 15. That means that the 5 in this box is in one of those cells. Can't go with the 1, or we'd need a 10 in the cage. Don't know much about this. Have we got a double or quadruple or anything? Not quite here. Do we know about the 19 cage? It doesn't have a 3 in it. Oh, it doesn't have an 8 in it either. Right, it doesn't have an 8 or a 3. Does it need a 9? Yes, it does. 7, 6, 5 isn't enough. So there's definitely a 9 in there. And then 10 more, which aren't 2, 8, or 3, 7, or 1, 9. Is that right? 10 more in the 19 cage. We can't use the 8 or the 3 because they're definitely here. And it can't be 9, 1. Yes, that's a 9, 6, 4 cage. And now surely that means we've used 4 twice in the first 2 columns, so they can't have a 4. That's where 4 is in box 4. If that is 1 or 7, one of the possibilities has gone. That is the one with the 5. Okay, that didn't resolve it. 4, 6, 9. So 5 is definitely in one of these 2 cells because it's now not in the either of the cages in the box, and that one says it's not there. 5, 3, 1, 2. Oh, 7 is the one number we haven't got in the first column. Yes, excellent. That's great. 7 there. That must be a 1 now. This is an 8-3 pair to make up the 12 total. That still doesn't fix whether this is 2 or 5. That's very annoying. This is now 2 or 5 as well. So that's probably done something. Yes, look, there's a 2-5 pair in the column. So now we know where 2 goes in this box. Sorry. Do we know more than that? We probably do. What else do we know? Two is in those 2 cages, so it's not here. It's been used up for rows 2 and 3, so that's a 5. That's 2. That fixes 5 and 2 down below. So all the outies are done in boxes 1, 4 and 7. Now this isn't 2, so 2 is here. 5, 8, 9, 1, 2. 3 is in one of those 2 cells, which is quite interesting because it's also in one of those 2 cells, so there must be a 3 up here somewhere. Ah, no. 3 is also in that pair of cells, so 3 is forming 2 sets of X-wings, which mean we know it's up here in the 18 cage. Ah, with another 15 again. Don't know quite how to make that up yet, but 4 must be in the outies there. Okay, 4, no, we've sort of done that. Right, haven't really used these 19 and 20 much, and I'm not sure how to yet. If the 19 had a 3 in it, it would be 397. Yes, we worked that out earlier. No, I don't know how to use that. Let's have a look at this 1, 2, 3, 4. Quadruple again. 9 gone in the column. 5, 6, 7, 8 still to go. God, I feel like I've done most of the heavy lifting here, but still not closing in quite on a finish. 1, 2, 3, 4 quadruple down here. So that's not a 4. 1, 2, 3, 5 quadruple up the final column. Look at that. So that's not a 5. So this is the 5 in the 22 cage. That's not. The 3, yes, in fact that's a 1, 2, 5 triple, so the 3 in the column goes there. That fixes 3 in this box. Now if we knew the cage total here, that would be very helpful, but we don't. Still 4, 6 and 7 to place in the box. 3, 3, 3, 2. Oh, so the 5 goes with another 15. Okay, I'm not done yet. This 16 cage has got a 1 in it, and either 6, 9 or 7, 8. 1 there. Sorry, hadn't seen that coming. Sorry if that's been sitting there for a while. Scanning like a stormtrooper again, just as I did yesterday when I thought I'd done a decent solve, but you guys are so good now that I can't get away with anything slow. 1 there, 2, 3, 4. Oh, that's not done anything for that. 3, 1, 2, 4, 5. Oh, my scanning. Come on. 4, 6 and 7 still to place in the final column. This 20 cage could still be. It's got a 5 in it, and it's going to use either 6 or 7 as well. I don't know how to use that. Come on. How about this 3 then? 3 there, 3 in one of those cells. Ah, so 3 here. That's just Sudoku. Right, there we go. Right, so the 3 goes with a 9 and a 7 in the 16 cage. The other outies there, 5, 6 and 8. The bottom one can't be 5. Now surely that's done something. Ooh, I've got a 2-4 pair in the central column. With a 3 there. I don't know what to do with that. 2, 3, 4 pair. No, that's been there for ages. 7, 1. Oh, 2 there. Looks straight back along here. There we go. That's fixing all the 3s there. Now, now look at this. I get 6 and 9 to fill in this column. And what's really beautiful about that is, in both of these cages, I've been looking for another 15 to put in and not knowing whether it was a 6-9 pair or an 8-7 pair. And this is suddenly telling me both need 8-7. Neither can have a 6-9 pair because they'd break the other, that 6-9 cell. So 1, 8, 7 there. That one can't be a 1. 3, 8, 7 here. So that straight away gives me a 7-8 pair. This is not a 5 anymore. In fact, the 5 in this box goes here now. I think we might be finishing off 7-8 pair, so that's not a 7. This one is 4, 6, or 9. No, we're not quite finishing off yet. Premature. 1, 5, 8, 9, 2, 3. I hope you're not hearing too much of the drilling noises or men laughing, which is the other noise of a construction site. Now, what do we do at the top? Something's become very obvious here and I'm not getting it. I feel that. Let's have a look at this column again. Oh yes, that 4 was looking down here. That doesn't get much done apart from those. 4 there. Oops, 4 there. So that's using up the 4s in columns 8 and 9. So now we know that this cage would have had a giveaway 9 total. I don't think it would have been a giveaway. But anyway, we know that that's what it would have been had it had its total. 3, 4, 5. So have we used up? I don't know. Still not done though. It's a very nice puzzle this. 2, 4, 3, 7, 9. That's not the only place for a 1. 7, 8, 6, 9 quadruple. I mean, if that's really necessary, it probably isn't at this stage, but amazing that that's still available. So we get a 1 at the top. This becomes 5. That 1 looks across to this box, and we get a 1, 6, 8 pair, which gives us a 7 over here. 6 up there. Takes 6 out of that. This can't be a 7. Oh, don't say this peters out as well. That's not a 1 anymore. We've got 7, 8 pairs up there. 4, 6, 9. This is a brilliant puzzle. To hold together still at this point is amazing. It's got to be this cage, hasn't it? If that's 20 and 6, these 3 add up to 19. And they've got a 4 in. Oh yeah, 4, 6, 9 or 4, 8, 7. I still can't see quite what that's going to be. So not quite there yet. What a puzzle. Just going to take the pencil marks out of there. Is that 4's not doing anything? Where are the 4's we've got? Still got 4's to place all over the shop there. Oh, look, the only place 5 can go in this column seems to be here. Yes, that should have been something I could have seen earlier. That 5 looking at that cell would have done it. So 5 there means we can place 5 here. That doesn't feel like it gives me anything massive. Oh look, a 4, 6, 8 triple there. Good God. So 7 or 9 there. This is 8 or 6. I don't know how to tell which yet. This is brilliant. So that doesn't resolve these cells either. Again, does that 7, 9 pair? It's forming a 7 X-wing with that 7, 8 pair. So this can't be 7. And that's all it does for me. I suppose it means this can't be 7. So that's 4, 8 or 9. That's not really very helpful. Maybe there's another X-wing going on somewhere. Oh my goodness. I'm sorry, I'm sure I am missing something very clear to you at this stage. But my head is getting fried. One of those has to be a 6 for the column, so that's not a 6. So that's a 7-9 pair. This isn't a 9. Another 4, 6, 8 triple that's doing nothing for me. 4, 6 pair in the top row that gives me though. So that's the 9. 4, 6, 9. Doesn't finish anything. Oh my God, I've got 4, 6, 8 pairs everywhere. 8, 9 pair and a 4, 6 pair. 2, 5, 6, 3. This is too much. Mr. Menace, you are a menace. What on earth is the resolution of this? In this row, 6, 7, 8, 9, 7, 8, 9. All these things are just hanging on slightly to the end. There's a 6 there. 6, 8 pair. Don't see how to use that. That's 4 or 6. 3, 1, 4, 2, 5. I mean, this is 6, 7, 8 or 9. I can't. It's the only cell I hadn't pencil marked. If that was a 6, this would be 8, 7, 9, 4. 9 there, 6. That's fine. I can't see the problem with that. My goodness, what am I missing? 4, 6, 8. That's 7, 9 pair, and that's 7, 8 pair. They just feel so relevant. Oh, come on. 6, 7, 9, 8. Wow, this is so cruel. Is one of those a 9? No, not necessarily. One of those is a 6. That's why I did work that out earlier. 7 or 9 there. So if that was a 4, 6, 8, 8, 8, 8. Oh, that would have become an 8. And that's impossible. So, is that right? If that was a 4, we'd get a 6 here, which would make that and that both 8s. Yes, a 6 here would be impossible, because those two would both become 8s. And you couldn't put an 8 in the bottom row. Wow. Okay, brilliant. Absolutely brilliant. And if that wasn't necessary, I apologize, but that feels incredible to me. So 4 there, yeah, we can do these now. 8 and 4 there, that fixes 6 and 8 there. We can do 4 and 6 at the top. Don't rush too fast now. I don't want to make a mistake at this point. 8's not there. Still haven't worked out what's in the 20 cage, but this can't be 6, so 6 is there. 9, 6 resolved. That has become a 7, 8, 7, 8. That's the top 3 boxes done. This now is a 9, and we finally know 9 plus 5 plus 6. 7, 8 there. 9 and 7 there. 7, 9, 6. 9, 7, 8, 7, and one more pair. 8 and 9, and that is the solution. What a brilliant puzzle. I love that. I hope you had a go at that. You may well have finished it much more smartly than I did. I'd be fascinated to know how you did. So thanks very much to Mr. Menace for sending it to us, and thank you for watching as always. Absolute pleasure, and hope to see you again soon on the channel if you like the content. Bye for now.